I'm Drew McDaniel. I'm a lead program manager in the Microsoft Azure team, and I've been focusing on Windows workload in IaaS. So I'll be covering two sessions. One session is going to cover how we put together the Windows workload and how that works on Azure, giving you some technical depth and architecture on how that works. The second session, we're going to cover a lot of the best practices and some of the common pitfalls that people have in using the Windows workload in Azure. When I'm not at work, which is a rare amount of time, I spend it with my three daughters, pretty much taking them to dance routines and dance competitions almost throughout the year.
Hey, we're back on the live stream for Level Up Azure IaaS for IT Pros events. I'm joined once again by Drew. We're going to be covering this a little bit differently from the last one. In this case, the topic of discussion is going to be around architecting your solutions, and also some best practices from a perspective of how to design stuff on the Azure platform. Don't forget, if you need to, you can reach out and ask us questions on the channel9.msdn.com webpage if you're watching this live. If you're watching this in recorded format, you can always go ahead and use the hashtag on Twitter, Level Up Azure, and we'll monitor that one for a while to see what kind of questions come in. But lots of goodness in this one, and also lots of questions lined up. So I'm just going to hand it right over to you, Drew, to kick this one off.
Excellent. Thank you so much, Rick. So similar to what we covered in the previous session, what we're going to dig through here is a set of architectural best practices that have come up from what customers are doing over the 3 years of virtual machines, both in the preview state and when they've been GA. And so this is leveraging the challenges that some customers have seen, areas where we've seen a lot of questions, and we're going to really deep dive into those in this session today. If there's some specific questions that come up that are not covered, we'll be taking those as we go through.
Great.
All right, so in this session, we're actually going to talk about a set of different things. We're going to talk about availability sets and how they apply and how they should come into your solution and when they maybe shouldn't come into your solution. Mm-hmm. We'll talk a little bit about when you should, an effective use of the temporary storage. This is our D drive storage that can be a challenge in some cases, but can actually be a great benefit in other solutions. We'll cover how to deploy a large number of virtual machines and the things in Azure that you'd want to know about and how to do that effectively to get a rapid deployment of hundreds of virtual machines. We'll talk about scale units, and then finally we're going to wrap up with some more coverage of different things we have in our preview portal that are being exposed to underlying functionality of Azure that you may want to make use of in your system. Mm-hmm. All right, so when it comes to your architecture in Azure, one of the very first things you want to think about is what we call an availability set. Now, an availability set is something that is used when you have two or more instances that are performing the same or similar task. So the example we're showing here is where you have a primary SQL server and a secondary SQL server. If you had a witness machine in there, you'd also put that into that availability set. That's what gives you that 3 nines and a 5 SLA availability in Azure Virtual Machines. What it does is it fundamentally tells the system, the platform, that these things are performing the same task and gives hints to Azure to spread those out across physical hardware and single points of failure. This applies both to Windows and Linux equally as well. So what ends up happening is you've got a machine, and so this is we're looking at what a physical blade looks like in Azure. We have multiple different types of hardware, and we'll actually talk a little bit about that in a bit. But each one of these have a set of physical machines. In the rack unit, there is a power distribution unit that provides the power to those individual machines, and a top of rack switch that is our networking gear for that rack. Those things, there's only one of those, and so that means that rack itself is what we call a fault unit. So when we're going to deploy a virtual machine, we have literally hundreds and thousands of these racks out across the world as part of in Azure. The virtual machine, when it's in an availability set, Azure takes that and spreads that out across the racks and across the physical machines. What this means then is, if then there's a problem on that rack, Azure will automatically service heal that instance over to another rack. Now, one of the reasons why you want to use the availability set is by spreading these out. It also spreads out when there's maintenance within Azure. And so the rack failure is one point of failure that we want to avoid, and Azure will recover that for you. However, on occasion, typically for security reasons, we need to update the underlying hypervisor that's running on those physical machines. And when we do that, we want to only take down a limited set of your machines that are part of that availability set. And the notion of the availability set is what allows Azure to know how to take those machines down. So we'll show this in just a minute as we deep dive into this in the portal. Now, a set of guidance that we have on using availability set. First is VMs in an availability set need to be in the same cloud service. The scope of an availability set is a cloud service. So if you deploy 5 different machines in 5 different cloud services and use the same availability set name, that really doesn't do anything for you. And so you need to have them in the same cloud service. And I'll show you in a minute how you can confirm that you have it configured correctly. The availability set has 2 components. It's a update domain and a fault domain. The fault domain is what causes it to spread out across the racks. We guarantee at least 2 fault domains within your availability set, but if you have more machines, we'll actually try to spread that out across racks, but we will just surface this as 2 logical fault domains in the portal. Similar update domains, what update domains is this is what we'll use when we come to platform maintenance. This aligns to a single physical machine. So an update, we spread across those update domains so we do not take down as many of your virtual machines at one time when we do maintenance operations. Now you get a maximum of 50 virtual machines in an availability set, and that's because you have a maximum of 50 virtual machines within the single cloud service. And so by putting the machines in a single cloud service, you can put up to 50 of those in that same availability set. Then the final piece is when using availability set, those are really designed for when you have multiple virtual machines that are performing that same function. So whether they're web servers or they may be Active Directory domain controllers or a cluster, those are great solutions for an availability set. Single instance VMs that are unique amongst themselves really should not be in an availability set. And one of the reasons why you'd want to avoid the availability set is that if you have that machine that is really a single instance, there's nobody else to back up that machine. If you put it outside of availability set, which is what we call our single instance VMs, and those actually get special notification before any update is done on those virtual machines. And so if you do not need to be in availability set, then it's best to be not in availability set. Although if you do need to be in availability set, you absolutely want to be in there. Mm-hmm. All right, so let's go ahead and jump into the Azure portal to get a little more view of what this is. So in the Azure portal, if you've used it recently, we've got a vCurrent portal, and this is our portal that is fully available, fully production quality. If you select in here your under your name, you also navigate to the new portal. And so we have this new portal, we call it our preview portal. So we'll be looking at both of these today. The preview portal has some functionality that doesn't exist in the current portal. That said, there's also some things still being added there. It's still a work in, it's still under development. And so it's a great thing to try it out, see what it is, but kind of day-to-day use, it is still this existing portal here. We call our vCurrent portal. Now, within our virtual machines, so I've selected our virtual machine. I've got a set of machines for demoing our availability set. And so if we select this machine, availability set 1, you'll actually notice that these all are in the same DNS name. That's because they're in the same cloud service. Mm-hmm. And when we select this machine and we go to the Configure tab, you will see that this machine is in an availability set called Demo. With these other 5 machines in that availability set. Now, if you want to see another view of the virtual machines and how they spread across those fault domains and update domains, what you want to do is you want to select the cloud service. So now we've navigated from the virtual machines tab to the cloud service tab. and I'm going into the cloud service of availability set demo. And now, if I click on the instances, this is actually the same view that you would see for our web and worker roles. It specifies the logical update domains. So here you see, and then the fault domain. So the first VM that was deployed went into update domain 00. The second one went into update domain 1, fault domain 1. And then, as I mentioned, you have 5 update domains. And so the count of update domains has continued. But you only have 2 fault domains, and so we've went back to 0. Now, it's important to understand that these are what we call logical fault domains and logical update domains. That means that it's not necessary that machine 3 and machine 1 are in exactly the same rack. Mm-hmm. They may be in the same rack. We just don't guarantee that they are separated. However, machine 1 and machine 2, because this is fault domain 0 and fault domain 1, those are guaranteed to be in separate racks. Similarly, the update domain, we can see here that even though machine 1 and machine 3 could be in the same rack, because the update domain is different, they're absolutely on separate physical pieces of hardware. Mm-hmm. Now, where this is going to come into play is when we do our maintenance operations. And what I want to show as we go into this, if you take a machine, one question that comes up is, what happens if I were to delete one of these? And so I'm going to come in here, and I'm going to delete AS3 that's in update domain 20. So we're going to come over to the virtual machine, select AS3, and I'm going to click over here and delete. Now, what we'll see at the conclusion of this is that go back to the cloud service. Now, at the conclusion of this, AS3 is going to go away. The existing machines are going to stay in their same availability set, update domain, and fault domain configuration. The reason this is that way, and we don't actually go and have number 3 become number 2, is that would require them to potentially move machines and take a reboot. And we want to minimize the number of VMs that need to be rebooted when we're adding or removing machines.
Right, because obviously rebooting is going to be affecting potentially the non-persistent storage, if there's any storage on there, and everything else. And one thing I wanted to clarify and actually ask for clarification on is with availability sets in this type of environment, the availability set is the way you've broken it down for structure inside the data center. Your application that's running on top of these VMs has to have its level of resiliency to be able to continue to work. Like your example always has SQL as an example for hot and cold, or different levels of SQL. If this is just a VM set of something, the actual application layer on top of the OS layer has to have some level of awareness of the fact that's running across 6 different machines. Is that correct?
That is absolutely correct, right? Yeah. So the application, in these cases, would be designed for running in a cluster with peers of machines. Mm-hmm. What you typically will see is, depending on the application, you may have a load balance endpoint. So if you have a load balancer in front of those actually will spread the traffic across those. So that's what you have in the web front end case.
Right.
In the case of a Active Directory domain controller, they don't necessarily use a load balancer, but they register as, say, DNS servers or domain controllers, and they actually take care of that themselves. But yes, the application is either aware of that, or it's an application that's maybe more stateless, like a web's front end, or a little lighter that doesn't necessarily have to have that shared state. That you can actually just use a standard load balancer.
And I do know there's also a bunch of questions in the queue about clustering, as in Microsoft clustering. We're going to be talking about clustering from a data center perspective just coming up, and then we'll address a lot of those clustering questions you might have in that section.
Absolutely, absolutely. And so here, as you see, we've removed that machine. These guys stayed as where they were. If we were to deploy a new machine, if I deploy number 7 here, then it's going to go and fill in that slot. And so number 7 would end up taking update domain 2, fault domain 0. What this means then is that you can look at these and you can know that when platform maintenance is done, so when we need to update the underlying hypervisor and the running the physical hardware, we will only take down machines within one update domain at a time. And so in this case, we see that AS6 and 1 are in the same update domain. Those would be taken down at the same time. But then those would be brought back up, and we allow a minimum of 30 minutes before we move forward to the next set of machines in the update domains. A key thing to point out here is it doesn't necessarily mean these update domains is not the order in which they will be updated. They may be updated in this order, but the guarantee is that we never take down machines, more than one update domain worth of machines at a time. So if you had 50 machines or if you had 40 machines in there, as I mentioned, you have 5 update domains. So what you're going to do is you're going to take down a maximum of 8 machines at any point in time for any kind of our maintenance operations. We used to have maintenance operation. I'd mentioned the fault domain captures and touches the rack. We used to have update domains that did impact the fault domains when we needed to do network infrastructure updates. We've changed how we do those updates, and so you no longer have VMs being rebooted because of network infrastructure updates, which is a nice improvement. Okay, so let's come back to the session. Okay, so that's a quick overview of availability sets, when to use them, when not to use them. And I said there's multiple blog posts that we have out there that actually give some more information on that. Now I want to talk about the temporary drive. So if you saw our earlier session, we actually showed a virtual machine, but the organization of a virtual machine is you've got an OS drive, typically C drive for Windows, that is in persistent storage. And then you can have multiple data drives that are also backed by Azure Blob persistent storage. But there's this temporary disk that is sitting there. We use that for the page file by default for Windows. But there's some additional things that you can do with that temporary disk, specifically on a new set of virtual machines that we label our D series of virtual machines. Now, our D series virtual machines take that temporary disk and always put that on SSD-based or solid-state storage devices that give you much higher throughput and lower latency. So there's some cases where you'd actually want to leverage that. Now, when it comes to guidance for the temporary drive, first off, you never want to place critical unreplicated data on the temp drive. Don't put your Active Directory database on temp drive. Don't put your customer database on temp drive. It is something that can be lost when the machine moves to a new host. It'll also be lost if you resize the virtual machine or if you deallocate the machine and reallocate it. So you really only want it for unreplicated temp data. That said, specifically we're talking about here in SQL, but there's for other applications some great reasons to use the temp drive. So for SQL, and we've actually got a pointer to the blog post on this, we do recommend using temp drive when using the D series of VMs for the tempdb and using buffer pool extensions. This will apply for the D series of VMs and also the G series of VMs, which we've just recently announced. Those both have SSD-based storage, and so those are great solutions to use. Great situations to use the temp drive for some of these operations. The G series of VMs not only use the latest generation of Intel processors, but the G series of VMs have a much larger amount of temporary drive space as compared to the D series, and so you can do some more unique things there. If you do use a temporary drive space, you recommend to using scheduled tasks to configure the temporary drive. And so if you configure directories or you configure ACLs and you need to recreate those, or if your application does not automatically recreate those, a scheduled task is a great solution for that. And again, the best way then to test those scheduled tasks is through the resize operation. Anytime you change the size of a virtual machine, it's going to recreate a virtual machine container, and that's going to cause a new temp drive to be created. And so it's a great way to test that your scripts and your solution all works as compared to waiting until you have a hardware failure and then it happened and you get woken up in the middle of the night. Now, when it comes to performance, and again, we've got a link to the details here. Our D series is the one where the SSD temporary storage will give you some great advantage here. The amount of IOPS and both read and write bandwidth changes as the size of the virtual machine changes. And so as you see here, based on the number of cores in the virtual machine, you get an increasing number of size of the temp drive. And then as the size increase, you have an increase in the performance, both IOPS and bandwidth into that temp drive.
This actually might be a good chance for Asmer. I was asking a question about possibly being able to convert from one A to a D, or a D to a G, or A, B, C, D, E, F, G, whatever it happens to be.
Actually,
so
yeah,
can you do a conversion?
That is a great question. The answer is yes, you can do a conversion. Give us 1 second, Asmer. We're actually going to cover a little bit as we talk about the scale unit and the underlying clusters that make up our compute infrastructure. We'll talk about when it's very easy to convert, and then how you do it when it's actually not quite as easy. So
Okay.
we will definitely cover that in just a moment.
Cool.
Okay. All right, so the next topic we want to cover is deploying hundreds of virtual machine. As I said, Azure you got the hardware at the ready to deploy the virtual machines. But to do the deployment of a large number of virtual machines, it is very useful to step back a moment and talk about some of the key concepts that make up the Azure hierarchy, the set of objects in Azure, and then that shows you how to kind of do this a larger scale deployment. So the item that we deal with from the platform side, top level item is a subscription. Now, a company can have an account and have multiple subscriptions, but within Azure we have this kind of subscription is our top level entity. And within the subscription we have, for compute, they go into a cloud service. Now, there can be 200 cloud services within a subscription, and then the virtual machines are deployed into that cloud service. Again, the virtual machine, you can have 50 virtual machines per cloud service, giving you a maximum of about 10,000 virtual machines. A virtual network is part of a subscription. You can have 100 virtual networks in a subscription, and you can put the cloud services, multiple cloud services, into the virtual network. So these are top level, these are kind of peer objects. A storage account is another top level peer object. That then contains the storage blobs. We use page blobs for the disks in Azure. And those are another component. If you missed this in the first session, we kind of talked about how you really want to have a limit of about 40 disks in an individual storage account to stay under the caps of the number of IOPS in the storage account.
Now, I was about to say, we should probably preface this information because this will be available on demand. Yes. These are current as of December 1st, 2014. Because if you're watching this later, you never know. These numbers might go up or might go down. As an example, the storage accounts, as little as a month ago, you only had 20 storage accounts and a default subscription with Azure. Now it's up to 100 storage accounts.
That's a great point.
So just, as always, whenever you're looking for resources on any kind of a cloud service, especially on the Azure side of things, because things change so frequently, always look for references that are the most current to the date that you currently are in right now.
Absolutely. And the link down here in the bottom, if you're watching this link, we will keep updated with the limits of the subscriptions. And so as we make those changes, these are what we have currently. Those will be reflected in this link dynamically on those sites.
Yeah, I guess maybe I should even qualify. The azure.microsoft.com site is where you're going to find the definitive, up-to-date current information. When you start to go off and look at various different blogs and different other resources on the net that other people have written at a certain point in time, that's where you might have a little bit of the aging out taking place that's in there.
Yes, the cloud changes and improves quite dramatically at a quite dramatic pace.
Correct.
Now, when you're deploying a large number of virtual machines, so those limits of what's the absolute that you can have are important. The other piece is what we call locking, and we've got that captured in here. Within there's some locking that happens in the system to preserve both the reliability and the health of the system that lead to something you need to take into account. So, in the case of a subscription, we do not have any specific locks, so you can do multiple operations against a subscription at a time. However, we do have absolute numbers of operations that can be run against that subscription. The key one here when you're deploying a large number of virtual machines is 120 create or add operations can be done in a 5-minute window. This is because the operation of adding a virtual machine requires some computing resources within the system, and so we need to protect that to make sure that there's enough resources for all of the customers to deploy the set of machines. And so that 120 create or add operations in a 5-minute window is a key thing to understand from a subscription basis. When we drop down into the next level for doing compute deployment, it's the cloud service. The cloud service, you can do one update operation to that cloud service at a time. So that operation can be adding disks to virtual machine, adding virtual machine, but you can do one operation in the cloud service at a time. And that typically takes about 3 minutes to actually get that completely persisted and deployed out. And so there's about 3 minutes of locking for each cloud service operation. Other things have a little bit less that comes into play here. The virtual network, there's a locking on the changes to the virtual network. So this is not adding virtual networks, but this is changing subnets or adding virtual networks, but not adding machines to the virtual networks. And so if you're changing your network, and you typically do this infrequently, you can only do one of those at a time. But when you're deploying virtual machines, you can deploy multiple virtual machines into that virtual network at the same time. Then when it comes to the storage account, we talked earlier about having the spreading the disks out across storage accounts, so you have no more than 40 disks in an individual storage account with the current restrictions and recommendations. We also recommend putting each disk into a separate container within the storage account, and this is because we do some locking to make sure that you don't accidentally delete a storage account that has disks in there. And so by spreading those out across the containers within a storage account allows you to have more rapid deployments.
Actually, since we are still on this page here, you mentioned the VNet piece. UB has a question there about once a VNet has been created and the VMs are in production, what would be the best way to be able to make changes to that VNet? Are you able to make changes, or is it a matter of having to go in and make a brand new and redeploy? What's the story there?
So UB, the question here with the VNet, it depends on what modification you're making. The best recommendation for the VNet is to create it with a fairly large initial address space.
Right.
Once you have that address space, then you can create your subnets. You can continue to add subnets into that VNet. You can even expand subnets if you have VMs in there. What you can't do is change the overall address space of that VNet right now. If you need to change everything in there, the easiest thing is probably going to be to take the VMs out of that VNet, create a new VNet, move them VMs over to that expanded virtual network. You also have the opportunity within a virtual network to link them together. And so you can do what we call a VNet to VNet connection, and then have the VMs talk across those two VNets. So that's another way to expand out your virtual network. The one caveat in doing that VNet to VNet connection, you do pay a very low cost on the gateways that actually do that communication between the virtual networks.
Right.
Now, so when doing these larger deployment, then kind of all of the different objects and the locking leads to the set of guidance for putting these together. So the first part is you want to deploy the virtual machines in blocks. Now you spread these blocks across the cloud services. The recommendation here is to use either 100 VMs in the block if you're using more than 500, or take your total amount of VMs and divide it by 5. This way you actually will get the most update domains available in the cloud services, and so you have a fewer number of machines that could go down at any point in time for platform maintenance. But if you're, say, deploying 500 machines, deploy 100 cloud services, deploy a VM in each cloud service in each block. This allows you to stay under that 5 minutes limit of the number of virtual machines. Right now, if you remember from the previous page, it's 120 adds in a 5-minute window. Doing 100 at a time in 5 minutes will stay under that current limitation, or that current throttle limit. If you actually see throttling, you will see a return an error of 503 service unavailable, or 429 too many requests. And this just depends on the version header. And earlier in the lifetime of Azure, the earlier version headers return a 503 error. Later, we actually changed this to a 429. So depending on the version header and the API you call, you'll get a different error code. But really, if you're building this out, you want to look at both of these. Now you're going to deploy in blocks, deploy across 5-minute intervals, spread your disks across storage accounts, so you have no more than 40 disks in each storage account. The next piece here is you want to limit the amount of Git operations you use during the operation. Again, there's an absolute number of operations that can be done in a subscription in that same 5-minute interval. So you want to, if you limit the number of Git operations, you're normally safe. It's well above the 120 limit, but you certainly don't want to be doing one every second for every VM. Use a virtual network for connectivity. That allows you to put those set of virtual machines into that one to connect and communicate within the same data center side network. You can do in a current virtual network, a current scale is 2,048 virtual machines within that virtual network, and so it should allow you to do fairly large deployments.
Yeah.
And then the final kind of recommendation here is if you're using custom images as compared to platform images, then you need to have that image available in each storage account where you create an operating system disk. And so when you're doing these large deployments, one thing you may want to do is have the operating system disks in one storage account. Put 40 operating systems or OS disks in that storage account, and then use other storage accounts for those data disks so you limit the amount of copying that you need to do for the custom image. Okay, so that just is a kind of a quick overview, set of guidelines. There's some scripts that you may find on the internet on doing this, but these are kind of the core guidelines that you really want to follow when you're doing these larger deployments within Azure. Okay. All right, so we're going to keep going, and so we're going to come back to a question we had a little bit earlier. I was talking about changing between the A size and the D size of VMs, and what I want to dive into here is what we call our Azure Scale Unit, or you may have heard people, I think probably Mark Rusinovich was talking about this, the Azure Compute Cluster. This is different from a Windows failover clustering.
Right.
This is our scale unit that we use within Azure to deploy the hardware out into the data center and around the world. Now, these scale units, each cloud service, so if you remember from the object hierarchy, each cloud service is bound to a single scale unit, and we'll show you how that kind of takes effect. There's also a construct called an affinity group. Now, the affinity group is also bound to a single scale unit. So if you are using affinity groups, and by and large, they're affinity groups you probably don't need to use as much anymore. You used to use them to have way back in Azure history, you use an affinity group to get located to the same data center. You can just say, hey, deploy this somewhere in North America and deploy this other one. I want them at least regionally close. Today, you select the region you deploy to, and so that aspect of the affinity group is no longer needed. And so in general, the recommendation is just deploy VMs without using the affinity group into the same region. Our network is very flat across the different scale units, and so you really won't see that latency impact there. Now, what it does impact, though, is that scale unit directly impacts what you can resize to. And this is going to get to a question we had a little bit earlier from UB, which was, how easy is it, when can I change from an A size to a D size, and why is it that I can't change in some cases? This gets into the specifics of our current scale units. So we currently, as you think about it, as we purchase new hardware, as new generations of systems come online, we build out new scale units using the latest hardware as it's coming available. Currently within Azure, we have 4 scale unit types that are visible to you as the customer. We'll show you how this is visible. And then a 5th that's been announced. And so the very first scale unit supports our original set of VM sizes, which is A0 or extra small, through A4, which was the original extra large name. That's both basic and standard. And so when you're using infrastructure service, you can use a basic virtual machine if you don't need to use the load balancer and some of the auto-scale functionality. But this just applies to both. The next scale unit or set of hardware that we have supports A0 through A7. So when you deploy a virtual machine, you may, and we'll show this in a moment, be able to change between an A7 and an A0 if you're on scale unit type 2. But if you happen to go to scale unit type 1 when you deployed your A0, you wouldn't be able to go to an A7. Scale unit 3 is specific for what we call our HPC VM types, or big compute. These are our A8 and A9 VMs. These are the ones that contain the InfiniBand. And so that scale unit is specific for those 2 sizes. And then the 4th, and this is our latest generation that's publicly available, scale unit type 4. This supports our D series of virtual machines and the existing A0 through A7. So everything existing other than the A8 and A9. And then the fifth unit that, again, we'll probably have a future discussion on here, which is our G series of VMs. Those are the new latest generation of Intel processor, and that will be our scale unit 5. So what this ends up looking like, we'll flip over to the portal. You can see directly the machine. So the best way to see what scale unit you are on currently is to select a specific machine. So for example here, I'm going to select my availability set VM AS1. And when you come into configure, you will see the sizes that are available. And so now if I look at this machine, I can see that I've got A0 through A4. This machine is running then on scale unit type 1. So I can change between these sizes, but if I want to move to a different size, I'm going to actually have to take a different tack, and we'll actually show that in just a moment on what we would do to move that to a new size. Now, as I mentioned, the cloud service is all in the same scale unit, and so AS1 and AS2, if you remember, on the same cloud service. So if I select AS2, I would get, as you expect, the same set of VM sizes. Mm-hmm. Now, if I go here and look at A7, this one was deployed, and it was deployed out to the scale set type 2. So now I can change this one between any of the machine sizes. A little hint, if you want to make sure you want to be able to change between an A7 and an A1, is that first VM in that cloud service, or in the affinity group if you're using affinity groups, is an A7, then you'll be guaranteed to be deployed to at least the scale unit set that can configure to all of the A series. Mm-hmm. If we go up down here, just continuing on the path, an A8 has can switch between the A8 and A9. Actually, let me go ahead and come back here. So one of the questions, like let's say that A7, I want to change to a D series of VM. What would I do to go about it? I can't change it directly here. Mm-hmm. So what you would end up doing is, if we go and look at our machine, A7, it's got its operating system disk. I can't change it to a D series directly. So what I'm going to do is I'm going to note down the disk name. I can copy it, or say it's fairly straightforward here. It's got the machine name in here by default and the cloud service name. And I'm going to click delete on the VM, but I'm going to make sure to say keep the attached disks. So now I'm going to delete the virtual machine, but keep the operating system disk. If I have my data disk, I'm keeping all my data disks. So everything about that machine other than the temporary storage is really stored on the disks. Mm-hmm. And so I'm going to go ahead and delete theirs, keeping the disks. And we'll let that run through. And when we come back, we'll show how we can actually move that over to a D series of VM. The final one that I want to show here is if we look at the 2-disk example we had earlier on. And we'll just look at this guy here. Oops, sorry. And if we look at the configuration here, you'll notice that this one supports all of the different sizes down to the D14, with the exception of A8 and A9. Again, so this means this is on that scale unit set, scale set type 4 that supports this wide set of machines. So again, if you were to deploy the initial VM being a D1, then you can change it back. But if you initially deployed, let's say an A7, and that deployed to our older set of hardware, potentially we didn't have the D series yet, then you need to go. We'll go through this process we're doing on our A7 VM to move it over to a D size.
So for this particular example demo here, you had an availability set and you deployed a machine that was a D series so that you could have this guy created so that he was an A series and be able to show us all of those?
Well, it just depends. So the way that it ends up working is if you deploy a D series VM, you're guaranteed to go on to the scale set that supports everything. This is the way that the system is currently. It's not necessarily guaranteed to always stay that way. Mm-hmm. If I deployed an A series VM, A1 initially, I may have ended up on scale set 3, or I may not have. It just depends on what's available within the data center at the time you do the deployment. what we do is that when you come up and you say, hey, I want a VM of size A1, the system doesn't know how many you're going to do, and so what we actually do is we try to find the cluster that has the most capacity, free capacity available, and we deploy there. That way, if you add additional VMs to that cloud service, then there's a capacity behind that. That cloud service is on a specific cluster, so we want to actually get you there on that cluster that has the most capacity, which is actually what you're wanting if you are using that size. If you want to mix and match, then the guidance is to use the largest size first. That gets you on the right cluster, and then just deploy your smaller VMs into that same cloud service.
And I know this is going to be a question that's going to be coming up, so I might as well just ask this on their behalf right now. You're showing this all through the portal. Is this possible to also query and do some stuff on the PowerShell side?
Absolutely, absolutely. So if we go in here, we're going to do this on the fly here. So
Nothing like demos on the fly.
So in PowerShell, there's a couple options. Get Azure service. And so we were looking at the one that was on all of them here is 2-disk. And let me get the actual cloud service name. The cloud service name here is just DrewM 2-disk.
Okay.
So get the service DrewM 2-disk. Didn't give me what I was thinking. I may have to get back. There is a commandlet that gives you all of the size available in that cloud service or in that virtual network. I thought it was in this one, but it's apparently not.
Again, totally understand.
Yep.
I just threw that completely out at you to see what's going to happen.
Yeah, and the other thing I want to point out is that as we deploy and as we get some of these newer sizes and advanced sizes, they may not always be available in all regions. The portal, the services portal actually will show you the different regions, but the portal here, we can actually show a little bit of that. So if we do our quick create, our A1 size, if we look in here in the different regions, we have all of the public Azure regions available. And so that size is available in all locations. But let's say that we were doing something like the 8 and A9. So this is a little more specialized hardware and not necessarily available everywhere. Here, it's dynamically shown. And if you look here, for example, Japan East is down here, not one of the Australia regions.
Oh, okay.
Similarly, if we go to the D series, which is kind of in between, it's not as advanced as and specialized as the big compute, but it is a little newer. Again, you don't have, so we have Japan West, but not Japan East. We don't have the two Australia regions. This size, the D series size, is something we launched in September. This one is rolling out to the world, and so we'd expect to see that worldwide fairly soon. Okay, and now coming back, and let's see that that A7. So we were looking to say, how do I change that from the A7 size to a D size? At this point in time, we'll go in, and that machine would have been removed. The one thing you need to look at is when a virtual machine is shut down, there's two things that happen. One, it brings down the container. But as I mentioned before, there's a set of leases that the system holds against the operating system disks to make sure that people other than the host system is not writing to that. And so I'm going to look to make sure that my DrewM, the A7 VM, is not showing up as still connected. Okay, and so we see here that disk, here's the operating system disk, is not attached to any virtual machine, so it's fully shut down and safe to use this on another virtual machine. And so here I can come in using the gallery. I can select the disk here, so it's already specialized and configured. I've got that A7, that's the OS disk. And I can come in through here, and now I can select to create a different size. And so now I can move it to our D size, set the same name here if I would like. A7, I could change the name here. A key point here is where I'm using a specialized disk. The name I'm setting here is just my display name within the Azure portal. The host name is already configured in the operating system disk itself, and so it wouldn't change the host name. I can go through and deploy this, and now I'd actually have my machine running as a D1 sized VM that was originally an AE7. So again, this is a tool you can, if it's a simple VM, you can go through it in the portal. If you're doing it for a large number of VMs, PowerShell is a great solution. You can actually capture all the configuration of the VM directly and then redeploy that in a little bit easier way. Probably a great solution for an article for a blog post here.
There we go.
All right. Do we have anything else pop here that we need to cover?
Well, so far we already talked about the your VNets, as far as from UB's question about the VNets and being able to basically allocate enough space in between them, that sort of stuff, because you have lots of space internally. Phil has one. Is there a cost difference between using an update domain or a fault domain? And is cost involved, or is it simply a matter of how we basically put our eggs in the baskets across the different clusters?
Great question, Phil. Yeah, so the answer is if you're using multiple update domains, multiple fault domains, there's no additional charge for that. There's no change to the charge. You just set your machines into the availability set if they are a workload that supports that and is good for that, and there's no change in the price that you would pay.
And another question that came up, again, just I don't know how much you got left there, but I want to make sure this one's covered, is we've been talking about clusters from a data center perspective.
Yes, thank you.
So Microsoft clustering is different than what we've been talking about so far.
Correct. So
And the question that has been definitely in the queue so far is, what about Microsoft clustering? Can you use this or not?
So let me talk about that. So so what we've been talking about is the Azure infrastructure clusters. For what we call guest clustering, which is running Windows failover cluster in a guest operating system. It is supported, but it's supported for a subset of operations. So for example, when you use SQL Server Always On, it's configuring a Windows failover cluster under the covers. What we don't have today directly within Azure is the ability to have shared storage in that's block storage. And so when you run on premises, you may have a storage array in the back end. You can actually have machines both physically connected to that storage array using the same disk. That's not possible in Azure today. But if your clustering uses what's called shared nothing, so it's clustered and it's using that for heartbeating and seeing which one's online, but storing the data into separate disks, separate attached disks, that's supported. If your cluster uses files, so Azure Files is an implementation of SMB, the SMB file protocol. That's another form of shared clustering. If your clustering solution uses SMB files, you can leverage that for shared storage. You then typically need to have a third machine or that file share as your witness. And so you can configure Azure Storage Files to be your witness, or you can have a third VM as the witness to make sure that if one machine goes down, it doesn't go into a split brain problem where it doesn't know if he can't reach the other guy or if the other guy's really down. And so that witness helps break those ties.
And just to also just be kind of a little bit cautious is the fact that you only have 2 update domains. So if you get 3 machines, you're going to have 2 of those votes inside one of those update domains, which potentially can end up causing some issues.
And this is actually why using the file share is probably a great solution to get that off of the virtual machine. That said, like I said, the update domains, you have 2 guaranteed. We typically spread those out further than just those 2, and so it's likely that you're in good shape. Okay, so the last set of things that we want to talk to in the last few minutes is some of the advances in the Azure portal. This is in our new portal. One of the key things that you can do in the preview portal that's not yet available in the existing portal or in PowerShell for that matter is role-based access control. What this allows you to do is it allows you to integrate with Azure Active Directory and define users and the rights that they have within your virtual machine. You can configure them to have full control, contributor, making changes to those virtual machines, or just be a read-only operator. And we'll show that in the portal in just a moment. There's a set of templates that you can leverage that allow you to do multi-VM deployment. And so, a great example here is the SQL Server Always On. This deploys a template that has multiple highly available SQL servers connecting to the file share as a witness, and also deploys the Active Directory domain controller. Again, setting these up using the best practices for availability sets to give the right high availability solution. We have continuing on those, we have a SharePoint farm that's available. Third-party solutions, so we've got DataStax building a Cassandra implementation spread out across multiple virtual machines within that portal, as well as Hortonworks and Cloudera, and just the set of things. And one of the things we've been investing in and keep building on is the set of applications from trusted ISVs. This is part of our marketplace program. We launched that just very early on last summer. We expanded that greatly with a lot of these templates that you see here in last October, and it's an area where you continue to see enhancements and additional applications being developed there. And so if you are a customer or if you're an ISV, this is a great solution to actually easily get out your best practice configuration out to the customers in these kind of template forms. We'll show this just real quick. So let's go ahead and jump over to the portal. So here again, we're leveraging the preview portal. And again, if we're running in the existing portal, you can come in here and select switch to new portal. And it's going to start up the instance of the preview portal. It's going to load this up.
I like how it keeps the old one open still, just in case.
Exactly. It keeps the old one open. This thing is really slick. So from a DevOps perspective, this is really where this is designed.
Right.
If you had something open, if you were in the middle of something, it actually keeps your surface available. So if I were navigating into a set of different virtual machines and I walk away, it typically times out in my logon session, which is what I want to do for security purposes, but it would leave that desktop as it was when I come back and connect to the portal. And so it's a really great solution as you start developing and running a large number of systems here. So a couple of things we wanted to show in the few minutes that we have. One is we mentioned the role-based access control. So now here I've got my availability set machine. I'm the only one configured in here right now. Let's say I wanted to add Rick in here. I could actually come in here and select as reader, and then I could add somebody from the directory here directly to become a reader into that virtual machine, or I could go up and do that on the cloud service to manage a set of virtual machines.
And that's the directory that's part of the Azure subscription that you're managing this from. It's not just my public Live ID or Microsoft account, correct?
Correct. So this is integrating in with the Azure Active Directory. Right. So that's definitely something as you leveraging Azure. The identity is a huge component of this. Azure Active Directory is definitely something that you want to look into and leverage there. It adds power. As we go forward, you'll see more and more solutions being built up on top of that, and what we're doing here.
And we're going to be covering that on day 4, just
Excellent.
in case you wonder.
Excellent. All right, the last piece here we just talked about, and I did want to show real quick, is those set of templates. And so where those come up, I could select here from Marketplace, or if this was, if I had removed this, I can come in here to the New. I want to click everything. I'm going to select Virtual Machines. What you see here is a very long list of applications from our recommended set. We separate them out into databases. You scroll down here, we've got things that are specifically grouped to Linux. And again, things show up in multiple places, so it just makes it easy to try and find what you're looking for. VM Depot, these are community images. But by far, probably the easiest thing that a lot of us would be doing is just coming in here and search is by far the easiest. And so if we want to do that SQL template, I can just type in SQL. It's going to bring up a set of machines. In case here WordPress is using SQL instance, here's my always on template. I can select that, and then from here I could go through and configure always on cluster to be used in an HA solution that's been deployed and configured in a best practice manner.
Very cool.
So it's very nice, very easy way to deploy, and a growing ecosystem every day.
Very, very cool. Any last thoughts? I've got some more stuff to be able to cover up just after this, but I think we managed to get through all of it, my
I think
friend.
we covered a lot of different things. There's probably some other things we'll dig into even more in some blog posts.
Yes.
I know we've talked about Let's see, we've got preview, premium storage coming, our G series coming.
Right.
We'll have some more deep dive into those as those come around here very shortly.
And actually, I'll just go ahead and just in case people don't know, what the place to be able to go off and find the Azure blog is at azure.microsoft.com/blog. And then under there on the right-hand side, you'll see that there's a special tab just for virtual machines as an example. Yep. That's where I find most of you guys on the IaaS team tend to write your posts, is to go up in there.
Yep.
So that's one great resource you guys can use. With that, I've got a couple of little closing notes. Obviously, first of all, thank you very much, Drew.
Thank you very
much. This was
Rick.
an awesome two-banger session that we just had for this one here.
Double-barreled.
Double-barreled for sure. Again, all these sessions are going to be available on demand from channel9.msdn.com and also eventually on Microsoft Virtual Academy as well, microsoftvirtualacademy.com. But I also have to do a quick little shout-out and a thank you to my other speakers that I had today. I had obviously Mark Rusinovich in session number 1, the CTO of Azure, Corey Sanders, your
My
boss, and ever caffeinated Mr. Corey Sanders all the time, always around. So thanks a lot for you guys for coming up and doing this. Now, if you're going to be following the live stream tomorrow, same time, same place, same bat channel, we'll be doing a deep dive into some networking stuff, into some storaging stuff, and then also going into disaster recovery services and even automation, because you showed some automation stuff
there.
too.
Yep.
Some cool people coming up for that one there. All the recordings within 24 to 48 hours on channel9msdn.com. That's our good place to be able to go off and find these videos after the fact. We had some questions about the slides, and more than likely the slides will also be available on a per-session basis, available from the Channel 9 session page. So I'll just double-check to make sure that we have authorization from each of the speakers. People to go off and to use those ones there. We are following Twitter for the rest of this week and also ongoing in case you're interested. I'm looking at the hashtag #LevelUpAzure in case you have any other additional follow-on questions. I can direct them to the appropriate people and get your answers if I can't help you up there yourself directly. And then finally, there's even some extra resources you can go off and try to use yourself. One of them is, first of all, as Mark Rusinovich mentioned, go off and try Azure now. In case you didn't notice, if you simply go up to simply azure.com in the top right-hand corner, there is a button that says Start Your Trial. Go off and give that a shot. But again, be aware, it is a consumption-based service. I don't think you're going to want to be spinning up any dozens or so D-series D5s or D6s because you go through your free credit a little fast that way because it is consumption-based. But if you want a short URL for that one there, aka.ms/try-azure-now. That's you there. And there's even an ebook that people have been sharing on the Twitter stream as well at aka.ms/Azure-book. That's a variable. And then finally on our tech center that we have on the TechNet side of things, the Tech Center actually has what they call a learning path you can go off and try, or a journey. And that one there is available at aka.ms/tech-journey Azure. Again, these are all targeted specifically towards the IT professional, the sysadmin, the LAN admin, just as day 2, day 3, and day 4 of this series is going through. I'm obviously going to plug my blog as well because I contribute to the blogs that's out there too. You can find me at regularitguy.com. I've got a series that I actually called Azure for Server Huggers that you can go off and follow there in case you're interested. And then finally, as where this particular course will eventually end up as well, you can go to microsoftvirtualacademy.com and take a look at stuff and filter by topic. One of them is Azure. You'll eventually see this particular offering that's up there. And with that, I want to be respectful of everybody's time. It's been a jam-packed day. Make sure you go back and take a look at some of these sessions, but don't forget to come back tomorrow, same time, same place, to be able to go off and check out day 2, where we're going to be talking about networking, storage, disaster recovery, and automation. And with that, thank you very much for joining us. Thank you again, Drew.
Thank you, Rick. Thank you, everybody, for joining.
And we'll see you tomorrow.